Howdy, howdy, howdy. Today I want to talk about solving a system of two equations in two unknowns by graphing. There are two main methods of doing this. One is to graph the, in this case, lines by finding like intercepts or just any 2 points and plotting those and then looking for the intersection. The other method, which is a method I recommend, is the one we're asked to do by this problem here that says solve this system of linear equations, which we're given here. And we're told to do it by first writing the equations in slope-intercept form. And that has a big advantage to it. And the reason why is because if you put them in slope-intercept form, you can very quickly determine if there is one solution, no solutions, no solution, or infinitely many solutions based on the slope-intercept form. So let's go ahead and do that. So I'm going to take these and copy them over to my Scratch work. Okay. So let's write these here. So we have negative 1/2 x minus 1/4 y equals 1 as our first equation, and negative 3/4 x plus 1/2 y equals negative 1/4. So you may notice that in the actual problem we're given negative 1/4 for that last equation on the right side, but that is equal to negative 1/4. Okay. So back to the actual problem here. So we're going to write these in slope-intercept form. So let's take this first equation here. So we have negative 1/2 x minus 1/4 y equals 1. So there's a couple things we can do. Some people like to eliminate fractions right away. Other people don't. I'm going to just leave them in for now because there's no reason to be afraid of fractions, and so let's just keep them around, and then we'll get rid of them if we have to. So the first thing I'm going to do is I'm going to add 1/2 x to both sides. And the reason we want to do this is because we want to get rid of the 1/2 x, the negative 1/2 x that's over here. We want to have just a y on the left side. So just keeping things color-coded here. Okay, so I'm going to use a little arrow here to indicate that this equation from before is equivalent to this equation down here by this action. And since it's actually equivalent, we can make this a double arrow because you can go backwards too. You don't have to, but you can if you want. Anyway, let's keep going. I'll keep using the double arrows because we can. So again, remember the point of this is negative 1/2 x plus 1/2 x. That's just 0 x's. Okay, so there are 0 x's here. In other words, there's 0 here. So I can just write this as negative 1/4 y equals 1 plus 1/2 x. Okay, I still want to get y by itself, and I've gotten at least y with a coefficient by itself, but I want y with the coefficient of just 1. So you can think of it as dividing by negative 1/4, or you can think of it as multiplying by negative 4. They're the same thing, of course. Right? Negative times negative is positive. 1/4 times 4 is 1. So this will leave us with 1y. But of course, if we're going to do that to one side of the equation, we have to do it to the other side of the equation. So let's go ahead and deal with this. So again, like I said, negative times a negative is positive. 1/4 times 4 is 1. So this is just a 1y, which of course is the same as just y. And on the right, I can distribute this negative 4. So we get 1 times negative 4 is negative 4. And 1/2 x times -4, well, that's the same thing as -4/2 x, right? The way you can make sense of that is this is the same as -4/1. So we have -4 times 1 is -4. And then 1 times 2 is 2. Okay? So, continuing, we have y equals -4 minus 2x. If we want to write this in slope-intercept form, this is fine, but a lot of people prefer to have it in the form mx plus b, so we'll start with -2x and -4 or plus -4. Both of those are fine. So again, I just want to emphasize all of these equations, these are all equivalent. Okay, so that's the first one. Let's go ahead and actually enter that in as our answer. So we have -2x plus -4. Oops. Okay, so we have -2x and -4. Now in this case, they're actually putting the graph in here for us. When we finish with this other one, I will point out how you would get this graph if you were doing it by hand. In this problem, the emphasis is on finding the slope-intercept form and then using the graph to make a conclusion. But you know, if you were going to actually graph it by hand, you want to make sure you know how this graph is created. But going back, so we have over here our second equation. I'm just going to copy it instead of rewriting it. Okay, so our second equation down here, I should label it like I did the first one. There we go. This is strange. There we go. That's what I wanted. Sorry about that. Okay, so once again, I'm just going to leave the fractions alone and just solve this as if it were any other linear equation. So this time I'm going to add 3/4 x to both sides of our equation. Okay, and now we simplify. As before, the whole reason we added this was that gives us 0 x's, in other words, just 0 plus 1/2 y, so we can just write 1/2 y on the left, and then on the right we have that -1/4 plus 3/4 x. Again, we want to get y by itself, so that means we want y to have as its coefficient just 1. So that means I'm going to multiply this by 2, which means we have to multiply the other side by 2 as well. Okay, and so we have 1/2 times 2 is 1, so this is just 1y, in other words, just y. And then I'm going to distribute this 2 over here, so we end up with -2/4 plus 3, I'm just going to write it as 3 times 2/4 to emphasize something here. And so we can simplify, right? We have -2/4 is the same thing as -1/2. And similarly, we have another 2/4 here, right? 2/4, so that's again just a 1/2. So we have 3 times 1/2, which is 3/2. And there's our second equation. So as before, let's go ahead and put this in our, oh, whoops, let's finish writing it in slope-intercept form. Sorry about that. Okay, so this would be y equals 3/2 x plus -1/2. Okay. So we have 3/2 as our slope. That's the wrong. Sorry about that. Okay. So we have 3 halves. Forgot this program is like that. Okay. And then plus negative 1/2. Again, this program automatically puts in fractions this way. The negative could go on the top or the bottom. It doesn't matter because they're both equivalent to negative of 1/2. Okay, so let's focus on this for a little bit now. If we were to graph these by hand, we would do so by looking first at the y-intercepts. This top one here, we have y equals negative 2x plus negative 4. So the y-intercept is at 0, negative 4, which is right down here. And then we have negative 2 is the slope, which means you can think of it as either negative 2 over 1, which would mean going down 2 and right 1. So from here, you go down 2 and then right 1. Or you can think of it as 2 over negative 1, which means going up 2 and left 1. So from here, you go up 2, left 1. So that's our line that starts on the upper left and goes to the lower right. For the second line, we have as our y-intercept 0, negative 1/2. So 0, negative 1/2 is right here. And then we have a slope of 3 halves, which means you can either go up 3 and right 2. So 1, 2, 3, 1, 2. Or you can go down 3 and left 2, because negative 3 over negative 2 is the same thing. So 1, 2, 3, 1, 2. Okay, and there's our 2 lines. Now I had mentioned that just from the equations alone in slope-intercept form, we would know how many solutions there are. You can see it in the graph, but let's actually go back here and see how that plays out as just the equations. Okay, so for the first equation, we had y equals negative 2 x minus 4, and the second equation was y equals 3 halves x minus 1/2. So writing them almost as we did here, but not bothering with the plus negatives. Okay. So what this tells us is, first of all, they have different y-intercepts. So since they have different y-intercepts, they are not the same line. And remember that when you're talking about a system of 2 equations in 2 unknowns, the only way you can have infinitely many solutions is if you have 2 copies of the same line. So we know there are not infinitely many solutions. However, we also know that they have different slopes. Okay, so since they don't have the same slopes, they're not parallel. And when you have a system of 2 equations and 2 unknowns, the only way to have no solutions is if the 2 lines are different but parallel. So in this case, we have 2 different lines and 2 different slopes, which tell us they're not parallel. So that means we have 2 different lines that cross in one place, and there is exactly one solution. So we know that the solution set will be of the form something, comma, something in this ordered pair, and we just need to figure out what those 2 values are. So let's do that. So it looks like the place where they cross is where x is -1 and y is -2. So let's put that in. Okay, but that's just what it looks like. We should make sure that that's actually what it is. Now, there's a lot of opportunity for mistake in here, right? So I suggest when you go and check your answer, you use the original versions. I don't know why it's doing this. That's better. Okay, so let's check our answer. So we'll take our first equation here and substitute -1 in for x and -2 in for y. And we'll see, does it actually give us 1? So a negative times a negative is a positive. 1/2 times 1 is 1/2. A negative times a negative is a positive. 1/4 of 2, well, that's the same thing as 2/4, which is the same thing as 1/2. And 1/2 plus 1/2 is 1, and that is precisely what we wanted. Okay, so we're happy there. Moving on to the second equation. Once again, we substitute -1 in for x and -2 in for y. And we hope that this will end up equaling -1/4. So negative times a negative is a positive. 3/4 times 1 is 3/4. Positive times a negative is a negative. 1/2 of 2, in other words, 2/2 is just 1. Okay. The thing is we want to subtract those two. So instead of 1, what I'd prefer is to think of it as 1/1. Okay, let's do that. There we go. And so I can multiply that by 2/2. So I have, oops, not 2/2. Sorry about that. Brain fart. That should be 4/4. And I just had 2/2. Okay, so we have 3/4 minus 4/4. 3 minus 4 is -1. 4 is our denominator, and that was exactly what we wanted. Okay, so we are happy. We've checked our answer. So now let's go and enter that in here. We have one solution. The coordinates were -1 and -2, and that's it. So I can submit my answer with confidence. Thank you very much. I hope you found this helpful. Have a lovely day.